In this class, we will study about the chemical properties of haloarenes. We know that an alkyl halide, that is RX, undergoes nucleophilic substitution that we have discussed in the previous classes, where we are going to replace this halogen atom with any other nucleophile like OH, cyanide, isocyanide, nitro, nitrito, like that. We have replaced that halogen atom with another nucleophiles. So it means that we have to break this bond. That carbon halogen bond is to be broken and another bond is formed with another nucleophile. That is regarding nucleophilic substitution of alkyl halide. Since our haloarenes also contains a carbon halogen bond, we might expect the same type of reaction could takes place in aryl halides also. But the nucleophilic substitution in case of aryl halides are extremely less reactive. That means are extremely less reactive. So what we are going to say here is aryl halides are extremely less reactive towards nucleophilic substitution reactions. Now what are the reasons for this? Why the haloarenes are less reactive towards nucleophilic substitution? Means there are two important reasons. One is due to resonance effect. I think the resonance concept is already discussed. I think you might have known about this resonance concept in the first PU itself. So I don't want to go in detail about this resonance. So I will give a simple hint here. Resonance is nothing but the delocalization of electrons. That means the electrons will move from one place to another place. So what is this resonance effect? Why this effect makes the aryl halides less reactive towards nucleophilic substitution? Means here, see, in the first structure of this chlorobenzene, as this halogen contains 3 lone pairs of electrons here, those lone pair, one of the lone pairs will involve in delocalization, that means in resonance. So when the lone pair of electrons enters the benzene ring, these pi electrons move towards the carbon and hence the carbon gets negative charge and chlorine gets positive charge. In this manner, these electrons will continuously delocalize from one carbon to another carbon atom. Finally, the electrons will go back to the same chlorine atom. So what we observe in these resonating structures means, among these 5 resonating structures, the 3 resonating structures, see the bond nature between carbon and chlorine. This is double bond nature. So during resonance, the carbon chlorine bond acquires some partial double bond nature. So in case of alkyl halide, there is only single bond here, so that we can easily break this bond. But in chlorobenzene, as the bond nature is partial double bond nature, so in order to break this double bond, it is very difficult. So the cleavage of this bond is difficult, hence the substitution of this nucleophilic substitution is also difficult. So this is one reason, that is due to resonance effect. And one more reason is difference in hybridization of carbon atom in carbon and X bond. So this is alkyl halide, this is aryl halide. Difference in hybridization of carbon atom. In case of alkyl halide, it is sp3 hybridized. In case of aryl halide, it is sp2 hybridized. Why? So what makes this concept will so that aryl halides are extremely less reactive towards nucleophilic substitution? Means here, see, greater S character in sp2 hybridized carbon. In sp2 hybridized carbon, the S character is 33%. In sp3, the S character is 25%. So in sp2 hybridized carbon, 33% S character is there, so that it is, if the S character is more, the electronegativity nature will be more, so that this particular sp2 hybridized carbon will have more electronegativity, and can hold the electron pair very tightly. So the electrons present in this bond will be strongly held by the sp2 hybridized carbon, so that the halogen moves towards the carbon atom, so that the length of the bond little bit decreased. If the length of the bond is more, so that we can easily break that. If the length of the bond is smaller the bond, stronger force of attraction will be there between the two atoms, and hence to break that bond it is difficult, so that the nucleophilic substitution is difficult. See, greater the S character in sp2 carbon is more electronegative and can hold the electron pair of CX bond more tightly, which results in shortening of bond and difficult to break the bond, and hence the aryl halides are extremely less reactive towards nucleophilic substitution reactions. These are the two important reasons. One is due to resonance effect, and the other is due to difference in the hybridization of carbon atom in CX bond. So this is the nucleophilic. For example, let us see an example for nucleophilic substitution. So even though it is difficult, we are saying only just less reactive. How to make the aryl halides to participate in nucleophilic substitution means we have to use under some conditions like high temperature, high pressure. See, so chlorobenzene, when it is treated with a base like sodium hydroxide, these are important conditions. At high temperature, at high pressure, we can make aryl halides to undergo nucleophilic substitution. So here the resultant product will be, in place of chlorine, will get OH, that is phenol. This is an example for nucleophilic substitutions in case of haloarenes. So this is about nucleophilic substitution. In the next class, we will discuss the electrophilic substitution.